Hi everyone, and today we are going to discuss this classical mechanics topics, and we are going to start with this Lagrangian formalism. And this starts with the constraints, right? We have to define what is meant by constraint is. We have to read about this, and once we solve problem using constraint, at that time I will introduce how we have to implement constraint in writing Lagrangian of a system, right? And we have to understand what is meant by generalized coordinates in order to describe the given system. Okay, depending upon the system, we are free to choose that coordinate, or we are very uniquely choose a coordinate in order to describe that system. Okay, but then we will be having D'Alembert's principle. D'Alembert's principle, which is nothing but Fi minus Pi dot is equal to 0, with the summation of in number of coordinates, generalized coordinates, right? So we'll be dealing with this, and with the help of D'Alembert's principle, we used to derive this Euler-Lagrange's equation, and we know what is meant by Lagrangian is. And once we have a Lagrangian, Euler-Lagrange's equation, and we will be getting the equation of motion of a system. Okay, so this is the procedure in order to get a equation of motion. Once you have to write Lagrangian, Euler-Lagrange's equation with the help of Euler-Lagrange's equation. Once we solve that with the help of Lagrangian, and we will be getting equations of motion. Okay, and this is the technique, this is the process. Once you have to write the Lagrangian, then you have to write the Euler-Lagrange's equation. With the help of Euler-Lagrange's equation, we will be getting equation of motion. We are going to use this process now to solve problems, some example problems initially, then we will be solving previous year's questions, right? And here we have some set of equations. You have to keep these things in mind. And first one is, what is meant by Lagrangian? Okay, Lagrangian, which is defined by L, and which is a function of q dot and t. And q is the generalized coordinate. Q is the generalized coordinate, and q dot is the generalized velocity, and t is the time, as you know, right? And L is defined as L is equal to t minus v, and t is the kinetic energy, v is the potential energy. As you know, L is a function of q dot and t. No other variables are found in this Lagrangian. Okay, once we write Lagrangian for the given system, we have this Euler-Lagrange's equation can be derived with the help of D'Alembert's principle, and this is the equation for the conservative system. For the conservative system, we can write d by dt of dou L by dou Qi dot minus dou L by dou Qi is equal to 0. This is the Euler-Lagrange's equation, which is the second order differential equation. And once you solve this, you will be ending up with the equation of motion of a system. Once you have a system, the equation of motion, which helps to predict the future of the system, or able to find the past scenario of the system. Okay, this is for the classical particles. Okay, and in next video we will be solving some example problems and some previous year question also. Thank you. If you like this video, please like, comment and share.